What's up, math fans? I've already introduced exponential functions in general, so now I just kind of want to give specific examples on growth and decay, and then I'm going to get to a Regents question over here. So first you want to put yourself in a real world situation because there are a lot of word problems like this. So let's say you start with $2,000 and you invest it either in a stock and it depreciates annually at 15%. So you got to understand depreciates means you're losing money. Annually means every year, and 15% is the rate. So if you understand what depreciate means, it means you started with all your money. That's 100% of your money. And when you lose, you're actually losing 15% every year. If you lose 15% every year, this 15 doesn't actually go in your formula. What goes in your formula is what you actually get back. So that what I get back is 100 minus 15 is what? 85%. And of course, in a formula, you're not going to use the percent sign. You're going to use it as a decimal. That converts, if you move the decimal to the left twice, that converts to 0.85. So if you saw my last video, you know the formula. The amount that I get is equal to the initial amount, which is $2,000, times my, in this case, it's going to be times my decay rate, which is 0.85, and that came from 100% minus the decay. And this, there's an exponent here because it's an exponential function. That's generally just your variable x, and x is going to represent the number of years. Number of years. Where it gets complicated is when they say months or decades or weeks. Then, and we'll get to that in the future. Right now, I just want you to get comfortable with annual. So that's it. If I was going to write a function, here's my function. You could see a, you could see f of x or a of x. Don't let that throw you off. Any one of those notations is fine. Then, it's not as simple as that. They might push you further and say, well, what's going to happen? How much money would you get in 5 years? So for this video, you might want to have a calculator. Any kind of calculator is fine. And take the 5 and plug it in for x. So you're going to figure out what 2,000 times, times 0.85 to the 5th power is. And I'm going to leave that up to you, okay? Type that in and you get your answer. I'm actually curious to know what you would do first. Please don't do 2,000 times 0.85. That's not correct. You want to make sure your calculator is doing exponent first, 0.85 to the 5th, then times 2,000. All right? So having a formula helps you to find the amount of money in any amount of years, not just one by one by one. You can go 10 years in the future, 100 years in the future, whatever. Let's look at number 2. Here you have something called population growth. All right? Population growth is going to be my exponential growth. What's happening here? My initial population is 500,000 and it's growing at a rate of 8%. So I put the 8% here, right? No, the number you want to put here is what is happening at the end of the year, which is, well, I started with 100%, and after it grows by 8%, growing means I'm going to add that 8%, and I'm going to end up with 108%. And remember what we do? We move that decimal twice to the left, so 108% becomes 1.08. Here's my growth rate, and of course it goes again to the power of whatever they say, and for this video, I'm doing annual, so x is going to represent the number of years. So there's your formula here, and again, I can ask you what the population would be in 5 years, 10 years, 20 years. Just plug it in, get your calculator, figure it out. All right? Here, it gets a little more complicated. I'm given a story, and they actually give you the function, so you don't even have to worry about the function. But I know there's my initial value, and I know that it came from depreciation of 25%. Decay of 25%. And they might even confuse you and say this happens every 10 years. That's why I use D for decades, 10 years. All right? So if I'm decaying 25%, that's 100 minus 25. That's why there's a 75 here. That's decay. Anything less than 1 means it was decay. All right? And then they might say, just rewrite that thing in terms of years. So you're going to say, in terms of years. So this stays the same. This stays the same, right? There's a 0 there. But instead of decades, in terms of years means, what's a year? 1/10 of a decade. I'm gonna use a different variable, y over 10. And what happens here is I can now write it as 1/10 y. Do you understand what I did there? I ripped off this, there's a coefficient of 1 here, so I just rip off the 1/10 and rewrite it like that. The reason I did that is now I can look at it like this. 0.75 to the 1/10 power. Get your calculator and do that, and you should get 0.9716. 0.9716, okay? And now it's in terms of years. All right, so that 714 stays the same. This was actually a multiple choice question, so it's pretty easy if you just guess and check. You don't actually have to go step by step. You just kind of take this and start playing with the exponent until it matches this, because the 714 never changed. Okay, so this is in terms of decades, this is in terms of years. All right, any questions, put them in the comment box and I'll try to clear it up for you. Thanks for watching. See ya.